Hello Internet. This is a very interesting repair today, and the reason why that's interesting is because Gigabyte watches my videos. And they heard my constant cry to not sticker their stupid stickers to the back of the board or the card. And they finally listened and they just started doing this. Just a simple tape, scotch, whatever, and look, the card is clean. I have access. I don't need to use any kind of chemicals to clean it up or whatnot, which is great. So, why is it here? Well, it was denied an RMA, and I think they pointed out to this damage here on the board, and it's normal when the GPU is getting shipped and not properly packaged. What happens is, as you can see here, you should be able to see it. It's like a slight angle. Yeah, so this corner here gets bumped and it hits the board, and depending on the layers that are in this general area, it could actually short some of the layers, but it's not common if that happens. So that was a reason for the RMA to deny the repair or warranty or whatever. And so here it is. The symptoms are, and I've already confirmed this, it will boot, it will post, but as soon as you run FormWark, even on like 80, 70% load, fans will go max, but it will still run. And if you fire FormWark full screen, or 1080p at the very least to give this thing, more or less close to 100% TDP, it'll black out. And the fans will ramp up even faster. They will go even faster than 100%. So that's very interesting, actually. Makes me wonder. You see, Gigabyte will deny RMA for whatever scratch they find. And I don't think this has anything to do with anything, though it might, but I highly doubt it. And regardless, this damage wouldn't be here if customer had a couple of inches of padding around the card all over, and I don't know. It got to me like that, so this was when the RMA guys got it. And one thing before I even remove the leaf spring, one thing I'd like to note is that the board is extremely bulged or bent or whatever you want to call this. So if I were to put a ruler here, you see this? See how curved this thing is? Yeah, and I think the reason why it happened was because in 2026, people continue not supporting their GPUs properly, so the board keeps sagging and ultimately creating ripped pads under the core or whatever, and here we are. So usually when blackouts like this happen, and when I say like this, I mean when it seems to work, but with the maximum load, it suddenly just shuts off. That usually means that there's a protection that kicks in, like a thermal protection or whatnot. Look at this. Look at this beauty, Gigabyte. Can you please stop it? It'll take me longer to clean this board just to get it prepared for work than to do actual work. And I don't have enough jars to put your stuff in. Yeah. And but benefit of collecting all this garbage is that I can probably use it on somebody's laptop eventually, because getting pads calibrated to a laptop is a very difficult process. So, as I was saying, I think that the problem may actually be one of the driver MOSFETs that is shorted out but still functions, though not properly, and it could trigger a thermal protection by the controller, and it might force the fans to go in the max, because it'll talk to the GPU and say, hey, there's overheating, turn the fans on to 300% or whatever. And here we have it. It'll probably shut down 1.8 volt, and then the whole system freezes. Not sure if there's a better way to handle this kind of problem instead of, because I mean, the safest way would be to shut down 1.8, and once you do that, everything just kind of gets killed with one shot on the board. And I don't mean killed like hurt or anything. It just, everything just gets turned off right away, because the whole sequence of voltage just breaks down. So I don't know. You would think maybe shutting down some specific signal, like trying to figure out which phase failed and just shut down that one phase, But no, the thing is, these controllers, power, PWM generators, whatever buck converters you want to call them, as smart as they are, they only have one single pin to monitor either the fault of them all or a fault of nothing. So if one driver MOSFET's bad, the fault signal is shared across all of them. So the controller doesn't really know exactly which phase is reporting a fault, and if it's configured the way to disable a circuit, then that's what it will do in the event of a failure. Not exactly sure how it's doing it. I never really studied that. Never had to really. So trying to get to the bottom. Good luck getting to the bottom of this. So this will need to be bathed in kerosene. I'm gonna collect as much as I can. Stuff is still soft and fresh, almost, and can definitely be used, and not just be used, but it will still be as efficient as it was day one. Because I don't know, I think they have a lot of silicone in this paste putty that will make it last a very long time, but it'll also make it drip. Silicone drip is not the best thing ever. It starts to drip under the core, you're gonna have problems with them high frequencies, overclockers. That might be an issue. So that's why I do not recommend this stuff. But who cares? Who cares what I recommend? They already gone as far as not putting that stupid sticker on the adhesive with the adhesive backing, so that's already good. So let's see. What I want to see is if all the power stages are working properly. So let's power this thing on. Gonna be looking at this thing with an oscilloscope, make sure every phase is looking correct, and if any of them are emitting any kind of noise, those will be the one to look into. Otherwise, we might have to just reball the core, assuming that there's a connection problem somewhere, given the fact that the board is extremely warped. So let's see. First, let's see if the resistance on 12 is more or less normal. Slowly charging, and when we flip the switch, that's perfectly normal. What else do I want to see? Another issue that I'm seeing right now, without even going too deep into this, is that without even well, actually, let me check that. I don't know if you can see this. Let me know, because I'm seeing something that I did not see right away, which I should have noticed. I don't know why I missed. If you're seeing it, let me know. It will be interesting. We might just have to put it back together and call it a day. So I want to see if any of the driver MOSFETs are heating up abnormally or anything like that. And looks like all of them are good. Yeah, the hot ones are the memory. Perfectly normal for them to look the way they do. So I'm not even going to test all the phases right now that I've seen what I've seen. And what I've seen is no paste on the core. I mean, there's paste, but it's half dry here. And the reason for crashes might be as simple as lack of ability to confirm that the hotspot is in the overheating state, in an extreme overheating. So this video is switching from hey, Gigabyte did something good, not putting them stickers, and the video basically switched from that to the evil behind a lack of hotspot temperature monitoring. Because as soon as I fire GPU-Z and I'm going to look at the temperatures, if I saw hotspot temperature, I would see that it is 20 degrees off or something. And so what ends up happening is, because we don't see that, the whole thing starts to overheat very quickly, and we don't even notice it. While the core temperature remains okay, the other half of the core, which is probably miles away from the actual temperature sensor, that's probably in the middle, this area here at the bottom was overheating to a point where GPU would just crash. And because we don't see the temperature of this area, we don't even know that ever happened. So let me go and flatten this thing out, or at least try, so that way we can put it back on board. Put it back in, and this thing is as twisted as my mind. Alright, I think that's starting to look good. Alright, so let's put that back in, reassemble everything back, and test it. Now, if just by replacing the thermal paste it works, then the reason for RMA denial was it was arguably valid and invalid at the same time, you would think. You see, the problem here is the board is noticeably warped, so that's 100% user error. That user failed to properly support the card, and so when the RMA gets the card and they're having some sort of issues with it, and they're just gonna start to find, they're just gonna look for any kind of excuse to deny you the RMA, except for looking for the cause of the failure and see what will take care of that, because that's what they do. That's their job. Um, and so, and you would think that the card comes with the anti-sag bracket from the factory in the box. People would use it, but people don't. So in that case, the fact that the RMA was denied due to a problem that has nothing to do with the problem is valid, even though it may seem like it's not valid. So in this case, I have to side with the RMA and not the customer. So, but we'll see. Regardless, even if that doesn't fix the problem might still be the fact that the board is extremely warped, and if it continues to crash, then reball most likely going to fix the problem. And even with that, it's still customer's fault, whether you like it or not. So we're gonna start with 680 resolution on Formark. That's gonna give it about 80 to 90% TDP on average. And I'm going to observe, we're gonna observe what the fans are doing. So right now fans are at 0. Remember, they were at 100% without any kind of sign of heat. You can see here a little bit of RPM, 30%. We should have been at 100 by now, but we're not. So let's wait. I didn't really look at the core temperatures much, but I did see that they weren't overheating by any stretch of imagination. But the fans went to the max, and right now fans are spinning at 30%. Okay, let's close this. Let's run 1080p. See what that does. And there we go. And we are still in business. Almost 100% TDP. The fans are barely over 32%. We're not crashing, and the reason for us not crashing is that we are not overheating. And that basically goes to show you that the hotspot temperature was a critical parameter that was, I don't know if it was intentionally removed or it was an oversight in the manufacturing process of this whole series. I don't know. Bottom line is, if we had the hotspot here, we would be able to tell exactly what's wrong with the card without even taking it apart. But it is what it is. So thank you for watching. Hopefully this was educating, maybe entertaining, and I'll see you later. Goodbye.